Hello everyone. Today we will be solving this coin games problem which is available on the Codeforces. Let's start the question by understanding it first. So there are n coins on table forming a circle, and each coin is either facing up or facing down. Alice and Bob takes turns to play the following game, and Alice goes first. Okay, so n coins forming a circle, and Alice starts the game, and some coins will be upside and some coins will be facing downside. In each operation, the player chooses facing up coin, removes the coin, and flips the two coins that are adjacent to it. Each player, each player removes facing up coin and flips adjacent coins. Okay. If before the operation there are two coins left, then one will be removed and other one won't be flipped as it will be flipped twice. Okay, so this is the scenario like this. Suppose there are only two coins are left. The upside facing coin will be removed and its adjacent coin is flipped once. This is suppose the right adjacent coin and this is the left adjacent coin. Then it will be flipped again. So it will be same. So the coin will be flipped twice. So it will be same if there are only two coins are removed and any one of the coin will be removing from that two coin circle, then the adjacent will be remain same. Okay. So if before the operation there are only one coin left, no coin will be flipped. Obviously, there will be no adjacent coin to that coin. So if before the operation there are no facing coin ups, the player loses. Okay, so only facing upside coins are allowed to remove. So if there are no facing up coins are available, then the player with the move at that time will lose. Suppose Alice is going to remove the coin and there are no upside facing coins are available, then it will be a loss for Alice. Yeah. Okay. So decide who will win the game if both of them play optimally. It can prove that game will end in a finite number of operations and one of them will win. This is the input format. First, t test cases are there, and number of coins are given as n, and and the I mean the uh, representation of coins is facing up or down is given in the form of string. Suppose this test case is there U T. So suppose it's forming a circle like this D U D. Okay, so it's given in the form of string. Okay, so this is the format. Now output format is for each test case print as if Alice wins the game and no otherwise. Okay, you can output any of your own. Okay, okay, fine. That's just 1 second. It's not working. Okay, let's leave it. Okay, so here suppose let's take this first test case. Do you Okay, so we are only allowed to remove any upside facing coin, and Alice will be making the first move. So suppose Alice removed this coin. So the next combination will be like this. Okay, the coins which are adjacent to this U will be removed. I mean flipped. And now Bob's move is there. So suppose he removes this. So it will be this. So now Elias's turn is there. He'll remove this. The Q will be there. Now Bob's turn will be there. Bob will remove this. The last coin will be Elias will play. And there will be no coins left. So Bob will not have any coins to remove. Then he will lose. Now this is the first test case. Let's take another test case for more reference. U D D U D. Okay. So suppose Alice removes this coin first, and the next combination will be D U Q. Now Bob will remove suppose this coin. Then next combination will be like this. Now Alice's turn is there. Then now Alice removes this D U, and Bob is also there. So suppose Bob removes this, then you Alice's turn is there. Alice removes this. No coins are left. Both of them will play optimally, but you can observe one thing here. At each operation here, two upside coins were there. Here, I mean, uh, let's take an example like this. That after removing this coin, that upside this coin, it will, I mean, adjacent to this coins, there were zero upside facing coins. Now, but as soon as I remove this, the number of coins will be, I mean, the number of coins in this are two, and in this is also two, and this is one. No, no, no. Forget about this. Forget. Sorry. Let's try to figure out any combination here. Try to pause the question, I mean, pause the video and try to think about any solution or any observation you can think of. So here, uh, after removing this coin, adjacent to this coin, there are zero, zero upside facing coins out there, right? But new two coins will be formed from after removing this coin, right? As soon as I remove this, let's take it separately. D, U, D were there. I removed this U and new two were formed. There were zero upside facing coins and two were formed. Okay, so this can be one thing. And in this operation, let's take it as well separately. As soon as I remove this, it will be so in the adjacent coins, one coin was there who was facing upside. Now after removing this, only one is left. Yeah, so we can make one observation as there. Suppose there are four possibilities of removing any coin. D, U, U, T, D, U, D. As soon as I remove this, adjacent coins are two. They will be zero, two, two, zero. As soon as I remove this, adjacent coin, one facing coin is there. There will be one. As soon as I remove this, one upside facing coin was there. One was there, and now one is also here. As soon as I remove this, zero were there. Now two are here. So you can observe one thing: number of coins. You can observe the number of coins. Parity of number of coins are not changing even after removing any upside coin from any combination. Okay, you can observe here. And now I hope you will know that if this is the thing, then whoever will start the game will win the game. Win the game, even if even there are n upside facing coins are there. Let me explain this with another example. Suppose allies will always start a game, right? So suppose odd number of bricks are there. In a place of upside coins, let's take the analogy of bricks. Suppose three bricks are there. Odd number of bricks are there. Okay. Odd bricks are there. Odd number of bricks are there. Okay. So allies will remove the first, Bob will remove the second, allies will remove the third, and Bob will not have any brick to remove. I mean, Bob will not have any upside coin as well to remove. So, with the help of this analogy and the parity of upside number of coins are not changing even after removing any upside facing coin. So, we can make a statement that as allies will always start this game, then if number of upside facing coins are odd, then allies will always win. Yes. You can uh, repeat this part of the question and you can think about it. Whenever there is a game of removing one by one things and there is no parity change is there. I mean, suppose the number of coins are decreasing. I mean, anything, any items. If their number is decreasing one by one, then and the condition is like this, the last player, I mean, the player with no item to remove will lose. Then, if the number of items are odd, then whoever will start the game will always win. Listen to this statement again and again and think about it. So we can code our solution with the help of this statement. Okay, so let's code the problem. Okay, so this is my boilerplate. So the input of number of test cases is here. Okay, so now calling a function call t number of right number of test cases per time, and the input format is length of the string, and second input format is string itself. Okay, so as we have made the statement n is odd, then allies will always win. As game is decreasing items one by one, hence player with first move will always win, as there will be no item left for opponent. Think about this again and again. So let's count the upside facing coins. Yeah. So now if uh, number of upside facing coins are odd, then allies will win. Otherwise, Bob will win. Yeah. So these are the test cases, and this is the expected output. Let's see if it passes. Okay, so what is the problem? So count is not defined. Okay, right, count. Okay, so it's passed. Let's try to submit this question, submit this problem. Yeah, so it's submitted. Thank you, everyone. If you have any suggestions, please comment down in the video. Thank you.